Hello, everyone. I'm Lee Hongmei from number 3 Vocational Technical School of Nanning. Welcome to this mini lecture. In the previous lessons, we have learned about information, data, signals, and data channels. In this lesson, we will study the technologies of data transmission. This mini lecture will cover 3 main topics. 1. The classifications of data transmission methods. 2. The technologies of data and signal conversion. 3. The methods of data transmission. The teaching objectives of this mini lecture are: 1. To understand the 4 classifications of data transmission methods. 2. To master the technologies of data and signal conversion. 3. To understand the 4 types of data transmission methods. Let's start with the first part, the classifications of data transmission methods. Data transmission methods refer to the ways data is transmitted over transmission channels. They can be classified into 4 categories. The first is based on transmission direction, which includes simplex communication, half-duplex communication, and full-duplex communication. In simplex communication, data transmission is unidirectional, with one party sending and the other receiving. The reverse is not possible. In half-duplex communication, data transmission can occur bidirectionally but only alternately, with only one direction transmitting data at any given time. Full-duplex communication allows bidirectional simultaneous data transmission, requiring 2 channels, one for sending and one for receiving. The second classification is based on the number of data bits being transmitted, which can be divided into parallel transmission and serial transmission. Parallel transmission involves transmitting data in groups simultaneously over multiple parallel channels, with each bit using a separate line, typically for short-distance transmission within data equipment. On the other hand, serial transmission involves transmitting data bit by bit sequentially over a single channel, with data being transmitted in chronological order. Serial transmission is much slower compared to parallel transmission, but is widely used in remote data transmission scenarios. The third classification is based on transmission mode and includes synchronous transmission and asynchronous transmission. Synchronous transmission uses a format of character groups or data blocks composed of binary bits. Asynchronous transmission, also known as start-stop synchronization, synchronizes characters individually. The fourth classification is based on signal type and includes baseband transmission, broadband transmission, and wideband transmission. Baseband transmission involves original electrical signals emitted by a signal source without modulation. Broadband signals involve modulation of baseband signals using carriers. Wideband transmission divides channels into multiple subchannels, each transmitting audio, video, and digital signals separately. Next, let's move on to the second part, the technologies of data and signal conversion. So, why is it necessary to convert data and signals? This is primarily because signals are the carriers of data during transmission, and they must adapt to the characteristics of the transmission medium. Additionally, optimizing channel coding and improving channel resource utilization are essential for enhancing transmission quality. How can we convert signals? This is mainly achieved through modulation and encoding technologies. Modulation is the process of altering the characteristics, such as amplitude, frequency, or phase, of the carrier signal based on the message signal. Encoding is the process of converting information from one form or format to another. Decoding is the reverse process of encoding. Now, let's study the third part, the methods of data transmission. Since the data types from the source can be either analog or digital, and the channel types can also be either analog or digital, 4 combinations of data transmission methods are formed: digital data analog transmission, digital data digital transmission, analog data digital transmission, and analog data analog transmission. Because analog channels cannot directly transmit digital data, in order to utilize analog channels for transmitting digital data, digital data analog transmission must first convert digital signals into analog signals, a process known as modulation. Different modulation methods have corresponding demodulation techniques. Three common basic forms include amplitude shift keying, frequency shift keying, and phase shift keying. Digital data digital transmission typically excludes direct current components. The code format should include a built-in synchronous clock signal. This facilitates the receiver to extract it for bit synchronization. Common digital signal encoding methods include non-return to zero line code, Manchester coding, and Manchester encoding. Analog data digital transmission requires analog data to be converted into digital signals through digital processing before it can be transmitted over a digital channel. The common technique for digitizing analog data is pulse code modulation encoding. Pulse code modulation is the primary method used to digitize analog data. Pulse code modulation involves three steps: sampling, quantization, and encoding. In China's pulse code modulation system, telephone signals are encoded using 8-bit coding, quantizing the sampled analog telephone signal into 256 levels. The sampling rate is 8,000 times per second, 8 kHz, resulting in a data transmission rate of 8 bits times 8,000 times, s equals 64 kilobits per second, known as the voice grade rate. In local area networks, digital transmission technology is primarily used due to the use of digital channels. In the early days of wide area networks, analog channels were predominantly used. However, with the development of fiber optic communication technology, modern wide area networks are now fully digitized, offering transmission cost and quality advantages over early analog transmission methods. Let's summarize the content of this lesson. In this lesson, we learned about the 4 classifications of data transmission methods, the technologies of data and signal conversion, and the 4 types of data transmission methods. Finally, to reinforce what you have learned, I have prepared some exercises for you to complete after class. I hope each of you will diligently complete them and internalize what you have learned. That concludes this mini lecture. Thank you, everyone.